In this lesson, we're looking at derivatives. The derivative is a mathematical operation used to determine the instantaneous rate of change at any given moment. For functions, the derivative is the slope of the tangent line at that point on the graph. So up to this point, we've been looking at the average rate of change by taking the for example, if we were, the average rate of change is the change over, say the change in y's over the change in x. All right, so if this graph, the green curve represents our trip, say from one point to another location, the speed would change over the course of that trip. If we wanted to find the average speed or the average rate of change over the course of that trip, we would take the distance of the entire trip and divide it by the time that the trip took. If we wanted to find out what was the actual speed or the actual rate of change at any moment, we would take the derivative at that value at that moment, at that x. So there are several rules to find the derivative of different expressions or terms. The derivative of a constant is always going to be 0. We use the power rule to find the derivative of powers. So if you have a function x to the nth power, the derivative of that is going to be, you bring down the exponent, and multiply that by the coefficient, and then subtract the exponent by 1. If you're multiplying two functions and if you have a function that is represented by the product of two functions, then to find the derivative of the product of those two functions, you take the derivative of one of the functions times the other function plus the derivative of the other function times the initial function. If you have a function represented by the quotient of two functions, the quotient rule allows us to find the derivative by taking the derivative of the numerator times the denominator minus the derivative of the denominator times the numerator, and then all of that over the square of the denominator. And then the chain rule allows us to find the derivative of the composition of two functions. So to do that, we take the derivative of the outer function of the inner function and then multiply that by the derivative of the inner function. Antiderivative yields the antiderivative of the derivative yields the function. They're inverse processes. So to find the antiderivative of a function, we're going to be doing the opposite of the derivative. So we're going to add 1 to the exponent and then divide that term by that new exponent once we've added the 1. And we also, for the antiderivative, we also need to add that constant because, again, whenever we take the derivative of a constant, we get 0. So since there are opposite processes, inverse processes, when we're taking the antiderivative of a function, we need to remember to include the constant. All right, so we want to find the derivative of this function. This is just a line. So the derivative is just, we're going to take the derivative of the first term. This is 3x to the first power. 1 times that coefficient, 3, is just 3. And then whenever I subtract 1 from the exponent, 1 minus 1 is 0. X to the 0 power is just 1. So that the derivative of 3x is just 3. And the derivative of 4 is a constant. Derivative of all constants is 0. So the derivative of this function is 3. Note also that the notation that I used for the derivative is a little prime symbol. There's several different notations for derivative. This is the simplest notation, is just using a prime symbol. Now note that, again, the derivative is the instantaneous rate of change. So the rate of change for a line is the line's slope. So slope of a line is the line's rate of change, and this line is written in slope-intercept form. We can verify that the slope of this line is actually 3, the same value that we got when we took the derivative. The derivative of this is a quadratic function. This is a parabola. So if we wanted to find out what the instantaneous rate of change is at any point on that parabola, we would take the derivative of that function and we would plug in the value of x that we're trying to find the derivative of the function at. So the derivative of 4x squared, we multiply the exponent by the coefficient and then reduce the exponent by 1. So 2 times 4 is 4 times 2. And then if we reduce the exponent by 1, we get x to the first power. And again, that second term is a constant. Derivative of a constant is always 0. 4 times 2 is 8. So the derivative of 4x squared plus 3, it is 8x. So if we wanted to find the instantaneous rate of change at any point on this parabola, we would just replace that point where we're trying to find the instantaneous rate of change at. We would plug in that value of x into the expression 8x. And for this function, we want to find the derivative. We want to find the derivative of this function, and we're going to need to use the quotient rule, because we have function in the numerator, function in the denominator. So we're going to take the derivative of the numerator times the denominator minus the derivative of the denominator times the numerator, all of that over the denominator squared. Derivative of 1 is 0. 0 times anything is 0. And then the derivative of 2x minus 2 is just going to be 2. And we're still multiplying that by the 1. If we squared 2x minus 2, we get 4x squared for the first term, negative 8x for the linear term, and then positive 4 for the constant. Negative 2 times 1 is just negative 2. And we can factor out a 2, and then the 2 will cancel with the all 3 terms in the denominator, giving us negative 1 over 2x squared minus 4x plus 2. Here we have a composition of 2 functions. The outermost function is the square root. I can rewrite that square root as that quantity to the 1/2 power. Innermost function would be that x minus 5. And so we're going to use the chain rule. We're going to take the derivative of the outermost function of the innermost function and then multiply that by the derivative of the innermost function. The derivative of the outermost function, we're going to bring down that exponent, the 1/2, and then reduce the exponent by 1. 1/2 minus 1 is negative 1/2. And then we still have the innermost function, x minus 5. And then we multiply all of that by the derivative of the innermost function. All right, 1 over 1/2 times x minus 5 to the negative 1/2 power we can rewrite as 1 over 2 times x to the minus 5 to the positive 1/2 power by putting it in the denominator. And then the derivative of x minus 5 is just going to be 1. 1 times that whole quantity is just going to be 1 over 2 times x minus 5 to the 1/2 power, and I can just rewrite the 1/2 power as a square root. We don't have to rationalize the denominator, we can just leave it like that. Now we want to find the antiderivative of these functions. Notice the notation, we're using a capital F to represent the antiderivative. So we're going to increase the exponent by 1. So we're going to increase the 5 to 6 and then divide that whole term by the new exponent 6. So 12 times x to the 6th power, and then put that new power in the denominator. And then we can simplify that. 12 divided by 6 is 2. Don't forget the constant. 2x to the 6th plus c. And we can always check ourselves. If we took the derivative of the 2x to the 6th plus 6, the derivative of 2x to the 6th would be 12x to the 5th. And then the derivative of any constant is 0. The antiderivative of this function, again, we're going to increase the exponent by 1, so that will give us x to the 5th power, and then divide that term by the new exponent. So 15x to the 5th over 5 plus 3. Right now we have 3x to the 0 power. If I add 1 to x to the 0 power, I get x to the 1st power, or just x. And then plus a constant. And then just simplify. 15 divided by 5 is 3. 3x to the 5th plus 3x plus 6 plus c. And again, you can check yourself by taking the derivative of that. You should end up with the original function. And lastly, let's correct this. All right, so we want to, again, increase the exponent by 1. 4 over 5 plus 1, or plus 5 over 5 is 9 over 5. Divide that term by that 9 over 5. We already have the 5 in the denominator. Stand by. All right, so we have the denominator, and then do the same thing for the second term. Increase the exponent by 1. We get 5/3. Divide that term by that new exponent. 5/3. We already have the 3 in the denominator, and then plus a constant. Move this over just a little bit. All right, and 5 times 9/5 is just 9. 3 times 5/3 is just 5. 18 divided by 9 is 2. 10 divided by 5 is 2. And we have the antiderivative of the function.